that what it's doing? It is doing that? Really? When you click on the ebook link, that's what it does?
I can sign out of everything and try that.
Yeah, you might want to sign out of everything and just make sure, or like delete your cookies, you know what I'm talking about, on your web browser, or just try a new web browser. Because like our homework assignments are going to come from here. So you open the ebook. Our first assignment is out of chapter 1. So I click on chapter 1. And then I go, well, it's already here, but I would go to 1.3, limits of a function, exercises. And so these are the problems that I'm asking you to do. Like you look at the schedule, and then you come here and you do the problems right here. And again, paper, pencil, you know, yes?
Do I create an account or like sign in with my school account?
Do you already have an account? No? Then just create a new one. Yeah. I'm going to give everybody, you know, a day to figure this out. Please reach out to me if you have any trouble, or if you continue to have trouble not getting into the ebook. I can send you just copies of the problems. All right, everybody has the formulas with the staple on it, yes? And the other one that's a single sheet. Everybody is signed in? What do you need? Sign in? Okay. Okay. I think that pretty much does it for the little intro to the course here. I've covered pretty much everything here. Go back to student view. Your grades will appear over here on the left. The syllabus, the modules, the files, the surveys for the end of the semester. Otherwise, it's pretty much it. Do y'all have any questions? Well, are y'all ready to do some calculus? All right, well, ready or not? Oh, I did forget something. Hold on. I did forget something. Make sure I'm in the right course here. Okay, here. Files. The notes. Okay, this is a pretty big thing I forgot. In the files, there's something called notes, all right? And if you click on that, you'll see a few files here. Chapter 1. This is a PDF file, which means that you can't edit it or anything. It's just a static file. But it has all of the definitions and theorems and things that I am going to be doing in class. So in class, I will be working on this board, and I will be using my notes here and working through them, all right? And so you won't have to sit there and write definitions down. It's all there for you in our files. What's different about those notes, the PDF static ones, and my notes, is that my notes are interactive. So I can actually like, what the heck is going on? Why is this not working? There we go. So my notes are interactive, so I can actually engage my notes and do animations and things like that. Those PDF files, you do not have that ability to do that. However, let me close this. If you see down here this thing called Wolfram Player Notes, those are the same files that I use in class that you can interact with. The difference is you have to actually go download a player in order to, it's free, it's just software that allows you to actually go and manipulate those notes. So if you're interested in that, go to, Google and type in Wolfram Player. And there will be download information to download the software. Once you download the software, then you should be able to download these files and then open them up on your computer and then be able to interact with the notes the same way that I am doing. All right? If you want, it's totally optional. Questions? All right, I'm ready. Let's start grinding this thing out. So we are going to we're going to start with a quick introduction of what Calculus 1 is, and then I'm going to cover a couple of preliminary concepts that you need to know some things you need to know. No way I can cover everything you need to know, but some of the major things. And then we're going to get into the notes, all right? So let's talk about what Calculus 1 is. Let me turn that light back on. I am recording. So what is Calculus 1 about? All right. So there's a couple of different viewpoints we can take on this, but I'm going to break it down to the most fundamental, something visual, something that most people can understand. And it's really this question. If you were given a function, all right, let's say I graph some function here. Let's call it f, all right? What we should be able to do today, right, without any calculus, is be able to take 2 points on this function, draw a line between them, and find the slope of that line. That we should be able to do. Now, you may not remember right off the top how to do it. We're going to actually do this, but that's something that requires no calculus. Give me 2 points on a function, draw a line between them, find the slope of that line. Right? So for this line right here, we should be able to find its slope. Now in college algebra, we usually call the slope of a line m, and I'm going to subscript it with SEC, standing for secant. If you have 2 points and you draw a line, 2 points on a curve, and you draw a line like that between the 2 points, it's called a secant line. And so this, we should be able to find the slope of that secant line. Right? That's without calculus. What calculus asks us to do is to see if we can, instead of doing this point and finding the slope of the secant line between 2 points, it says if we go to just 1 point, just that point, okay, can I find the slope of the line through that point? But that's weird because for a line, don't you need 2 points? Right? You need 2 points for a line. So what do I mean, can I find the slope of the line through that point? Well, imagine that we're moving on this graph. Like, imagine you have a point somewhere on here. Imagine having a line that goes through that point. Well, I'll put it here. Through that point, forget that one. For that point, do you all agree that there's an infinite number of lines that goes through that point? Right? All of those lines go through that point. The question is, what line makes the most sense to be at that point that would run tangent to this curve? This idea of tangent means it's kind of like just balancing on that point, just barely touching that curve. Right? This is not a tangent line because it's punching through the curve. Do you all see that? We're trying to find the line that runs tangent to it. So it would look something like, hopefully you agree, something like that. Do you all agree that that looks kind of like what a tangent line would be at that point? The calculus question is, what's the slope of that line? And that's it. That's the heart of calculus, is if we could find that, can we find the slope of that tangent line? That's in a nutshell, that's what calculus 1 is about. Finding the slope of a line that goes through 1 point. But here's the problem. Okay, here's the immediate problem we have when we get to something like that, and that is this. When you look at the slope back from college algebra, it's rise over run, right? That's how we define slope. And so if I'm trying to find the slope between 2 points, right, I need to know the rise. Like when you go from here to here, what's the rise? We could almost look at it like a right triangle. So this would be the rise, and this would be the run, right? The left and right is the run, the up and down is the rise. This rise divided by that run would be our slope. So if slope is defined to be the rise over run, then what is the problem about talking about the slope of a line at a single point? I mean, if you're at 1 point, you don't have a rise or a run, do you? because it's only one point. See, we can only define slope in college algebra if we have 2 points, right? 2 distinct points. Then there will be some run and some rise. But if it's a single point, we don't have a rise or a run. You could argue that at this point the rise would be nothing because you're not going up at a single point or down, and you're not going left or right, so you're dividing by 0. So you have 0 rise, 0 run. And so this is the question right here that we have to address. Does 0 over 0 make any sense? And right now it doesn't, right? We were told a long time ago you cannot divide by 0, right? You can't divide by 0. We've accepted that as truth, right? So this is really like the heart of everything in calculus is does it make any sense to actually talk about the slope of a tangent line at a point? Does it even make sense? So I'm going to go back a little bit further. There are two individuals that actually came up with calculus, all right? The fathers of calculus. At the time, the people are Isaac Newton. Most of you have heard of Isaac Newton, right? He's also done a lot of stuff with physics. Isaac Newton's, and then last name, the guy's name was Leibniz. Those are the two fathers of calculus. And what's kind of amazing is that they came up with calculus on their own, independently of one another. They didn't know that the other one was working on it. And they developed calculus without having any, it just didn't exist. They created it, right? And they were trying to get past these certain issues. So I'm going to show you the problem that they were trying to get past, right? It goes back to this idea of rise over run. Do we know the definition of the speed of an object, or I should say the average speed? The average speed of an object. By definition, this is the distance that the object travels divided by the time that it takes to travel that distance. That's your average speed, distance over time. So let's say I'm going to draw it graphically. Let's say that this is time, and let's say that this is distance. Let's say you decide to drive to Austin, all right? So I'm going to measure this in time in hours. I'm going to measure distance in miles. So at the beginning of the trip, you've gone nowhere, right? You haven't traveled anywhere. Time is 0. Okay? You start driving. Start the clock. Time goes on. I don't know. It's going to be a weekend. It's going to take us a while to get there. So we're driving, and we get to Austin. I don't know. Let's say it's 70 miles. Takes us 2 hours to go 70 miles. What is our average speed? 35 miles per hour, right? So how do we get to 35 miles per hour? Distance is 70. We went 70, and we divide that. This marker sucks. All right, let me try the blue. We take the 70. That's the distance we travel, right? 70 miles. And we divide it by the time it took us, which was 2 hours. And 70 divided by 2 is 35, and then miles divided by hours is miles per hour. So this is 35 miles. I'm going to put mph instead of miles over hours. That's our average speed, right? Geometrically, though, isn't that just the slope of the line connecting these 2 points? What's the slope of that line? Well, what's the rise? 70, and what's the run? 2, and 70 divided by 2 is 35, right? Y'all see that? So the slope of that secant line is equal to the average speed, right? And that would happen for any trip we ever take. Here's the calculus question. Were we going 35 miles per hour the whole time? No, we sped up, we slowed down, right? Sped up, slowed down. Maybe we got stopped on 35 completely. Who knows, right? So the calculus question is, all right, right, let's say there. How fast were you going? Were, not where. Were you going? How fast were you going, right? There's a problem with asking that question because speed is the distance you travel over the time it takes you to travel that distance, right? So to talk about the speed at an instant in time means that you aren't going anywhere, right? You have no distance traveled at an instant, and no time has gone by in an instant, right? So the speed here, if we try and do the slope, or try and do this definition, not the slope, we try and do this definition for this point, the distance we travel is 0, and the time it takes us is 0, right? And 0 over 0 is undefined. And Newton and Leibniz both said this is not acceptable. We should be able to figure out how fast you're going at that instant. One thing we could do is instead of looking at the entire trip, we could just pick a point really close to it, right? Like really close, and then draw a little line between those two and find the slope of that line. And that would be pretty good, right? And if we could zoom in and zoom in and zoom in and get a point real close, then we would have a pretty good answer, right? So this is the problem they were tackling, is that, is there a way, mathematically, is there a way to make 0 over 0 make sense? That's it. That's what they wanted to do. And from that, calculus was born, all right? So that's our main goal right now today, is to see if we can ever see a scenario where we can make that make sense, all right? You all understand? We'll get more into it, but 0 over 0 is what we're trying to get around. So let's do some preliminary stuff. Prelim stuff, all right? So what are some things I expect you to know? Given 2 points, you should be able to, 1, find slope of line through the points. 2, find the equation. I'm going to put EQ, period, of line through the points. Right, those are 2 things I expect you can do. So let's just do an example, all right? So as an example, let's say I give you these 2 points, 3, -4, and the point, let's go with -2, 7. So I give you 2 points, right? We could graph those points, plot them. There's a line connecting those 2 points. I want to know first, I want us to find the slope through them. And 2, find the equation of the line through those 2 points as well. We're going to need some formulas for this, all right, to do this. So the first formula I'm going to need to do part 1 is the formula for the slope of a line through 2 points. And we call that m, and the formula for that is y2 minus y1 over x2 minus x1. So it's the difference of the y coordinates divided by the difference of the x coordinates. That should look familiar, yes? You remember that? College algebra? Okay, so for us over here, we have 2 points. I get to label them however I want. I'm going to call this x1, y1, this one x2, y2. You could have done it the other way around. You could have called that x1, y1, and this one x2, y2. Everyone would get the same answer. So it doesn't matter the order. You just have to, one of them is the x1, y1 point. The other one is the x2, y2. And now I just plug into this formula. So So the slope of that line would be, let's see, y2 for us is 7. Take away what? Take away -4, so we'll have a double negative there, and then over -2 take away 3. Right? So the top is 11, and the bottom is -5. And this would be a good opportunity for us to remember also something about fractions when you have negatives, that the negative can live on the bottom, like this. You're free to move that negative to the top, or you're free to move the negative out in front. So a negative sign can float on a fraction. What you can't do is, if you have a negative on the bottom, you can't just throw a negative on top as well, because a negative over negative is positive, right? So any of those three answers would be acceptable as the slope of the line connecting those 2 points. That answers part 1. Part 2 is to find the equation of the line through those 2 points. And to do that, we need another formula. The formula is called the point slope formula from college algebra. We're going to use these formulas a lot. The point slope formula looks like this. Y minus y1 equals m times x minus x1. Okay? That again should look familiar to you. What this formula is a formula that will always give you the equation of the line through two points if you know one of the points and the slope of that line. So all you need to know to use this formula is one point and the slope. Do we have 1 point? We have actually 2, but we only need 1 for this formula. And then do we have a slope? Well, we just calculated the slope, right? So all I'm going to do now is I'm going to, into this formula, this m is going to get replaced with this. And then x1 is going to come from here, and y1 is going to come from there, and just plug and chug, right? Just plug in everything. So this becomes y minus, what was y1? -4, and then equals the slope, which was -11 over 5, parenthesis, x minus x1, which was 3. And that, as it sits, is the equation of that line, all right? That is the equation of that line. Now, I could clean it up, though, right? I could make my double negative become positive. I could even distribute this through if I wanted. I don't have to, but I could. So I'm just distributing through here. And then I could subtract 4 on both sides, right? And get y by itself. All right, I'm not going to. We could do that algebra, right? So I'm just going to box this. This is good. All right, so I will try when I can to show visual aids on this thing. I'm going to go to Desmos. You all heard of Desmos? It's a great graphing utility website. I'll use it periodically in here. What I'm going to do is I'm going to have it first. I'm going to graph those 2 points first. So it was 3, -4. And then the other point was -2, 7. For those of you who, I'm going to leave that there. For those of you who've used Desmos, I'm in no way an expert in Desmos, but I do know some little tricks in it that are pretty cool. If you're trying to change the scale of things, you can zoom out and zoom in just with your mouse. But if you hover over the y-axis and hit the shift key, oh, I thought I muted my phone. Sorry about that. Let me mute this. Okay, so if I hover over the y-axis, and hit the shift key and drag down or up, all that does is scales the y-axis. And if I do it on the x and hit shift and do that, it just scales the x-axis. It's kind of convenient when you're trying to change the scale of things without changing everything in every direction. But those are my 2 points, right? And now let me do the equation down there. I'm going to type in y plus 4 equals -11 fifths. Almost there. Plus 33 over 5. There we go. Right? So we found the equation of the line that goes through those 2 points. We need to be able to do that. Right? That's just a skill we need to be able to be comfortable with in here, or things will get ugly fast. All right, what else? Well, there's a lot of other things, but that going in, that's probably the main thing as we start here today. I do expect that you know the unit circle. So like right now, I don't want to put you on the spot, but this is more of a like cosine of 60. Every one of you sees that a different way, right? Some of you want your calculators right now. Some of you are thinking about the graph of the cosine function. Some of you are thinking about a unit circle. And some of you are thinking, why am I an engineering major, right? So, I mean, there's a lot of different thoughts going through your head here. Who knows that? That's the angle. 60 degrees could be written as pi over 3. I agree with you. If we want to look at it in radians, we use 60 degrees or pi over 3. But what is cosine of that? What is it? You gonna raise your half? Did I hear anything else? I thought I heard something else. It's the x coordinate. Okay, so I'm going to go to, so what I'm doing here is I'm trying to show you the way that I think the most efficient way to know this is, and that is you need to know your unit circle. This is a circle of radius 1. 1. And you need to know the common angles. Yes?
It's root 2 over 2, right?
Well, that is somewhere on here. It's not quite that one, though. Okay? So where is 60 degrees on this? What are the important angles? 30 degrees, 45, 60, and then there's a bunch of them, right? Okay. But you should at least be comfortable with the first quadrant. You need to know the points that correspond to those three. Actually, those as well. So this point here is the point 1, 0. This is the point 0, 1. This one is root 2 over 2. This one's root 2 over 2. This one is root 3 over 2, 1/2. And this one is 1/2 root 3 over 2. Those are your common angles and your common points. And so when we're asked to find cosine of 60 degrees, we have to know that when we're talking about cosine, we're talking about the x coordinates on that picture and at 60 degrees. So if you go to 60 degrees right here and you go and get the x coordinate is 1/2. So the answer to this is 1/2. If I say what is sine of 60 degrees, the difference now is because I'm using sine, we're talking about the y coordinate. And so the y coordinate 60 degrees would be root 3 over 2. That root 2 over 2 that you mentioned, sir, right? That would have been what? Sine of what? 45, right? That would have been root 2 over 2. It also would have been cosine of 45, wouldn't it? Cosine of 45 would also be the same root 2 over 2. Yeah? So the better understanding you have of the unit circle, the easier things are going to flow for you. If you're not sure about the unit circle and you feel like you need to have some refreshment on this, come to me for help or tutoring lab or something. I think given 10, 15 minutes, 20 minutes, I can make you feel a lot better about that. But if you're looking at it and you're like, I have no idea what's going on, it's going to catch up to you. You're going to get to a point where you get bogged down on a test on something like this where other people are just getting that answer in 10 seconds. So that's another thing I expect you understand is the unit circle. And then there's other stuff, but let's get to the notes. I didn't do it today, but usually I bring up 2 pictures from the internet. I'll just draw them. Okay, that's a block of cheese. And that's another block of cheese. And this one is this kind of cheese. Swiss cheese, right? So what's the difference between those 2 cheeses?
One is whole
One has holes. The other one doesn't have holes, right? Everybody in here, your math is at different places. Everybody has holes in their math, okay? Everybody in here, you have holes in your math. The question is how many, how big are they, right? So I'm going to try, as we move through the course, to identify, help you recognize where the holes are, fill them as needed. But truthfully, if you have too many holes and they're too big, it will be impossible for us to proceed. I mean, so it really is going to depend on you to say, hey, you know, I have more holes than I thought I had, or something like that, right? So you'll have to engage me on that. I can't just assume by looking at you, oh, they don't, you know, they're good, they're not, right? So you have to let me know when I get to a point in here and you're like, I have no clue, raise your hand, right? Raise your hand. There's no shame in asking questions in here. I think I'm ready. You ready? Do I talk about that? I'm not talking about that. Do I? Just one quick thing. If I write this function down, f of x equals, let's say, 3x plus 2. And I say to you, find f of 4. What's your answer? 14. All you're doing there is what? Plugging in 4 for x, right? So you get 14 here. Replace that x with 4. 3 times 4 is 12 plus 2 is 14. All right. Visually, what this means is this. If we go and graph this function, if you go out to 4, you go up to 14, there's a point there, isn't there? Right? So this number right here is always just your x value, right? So your left and right. And this right here is your y value, which is your up and down. All clear with that? I thought about not doing it because for most people it's like, yes, I got that. Like, all right. Now the notes. So I'm starting, remember, in 1.3. I'm skipping 1.1 and 1.2. 1.3, I'm going to show you a picture. There's a function right there. See this function? F of x equals negative x cubed plus 4x squared. I would like to know what f of 2 is, right? So if you can do it in your head, do it in your head. If not, do it on paper real quick. What is f of 2? So that's negative, and then you have to take the 2 and cube it, then plus the 4, and then take the 2 and square it, right? That's negative 8 plus, what's this? 16, and you get 8. Right? So when you plug 2 into that function, you get 8. Follow? Here is a picture of that function. Right? I've graphed it for you. But you can y'all see it in the background?